Welcome to Geometry Pro AP. Today we're going to do a lesson about rectangles, rhombuses, and squares. All right, you might want to take a second to pause the video and write the essential understanding, which is parallelogram in the take notes box below, which I'm going to put on the next page. Have basic properties and their sides and angles that may help identify them. The diagonals of these parallelograms also have certain properties. So if you want to also, you could write these definitions, but they're on the next page, which I'm about to show you. Okay, so the key concepts here. A rhombus is a type of parallelogram with four congruent sides. So it is a parallelogram with four congruent sides, and this is our picture. All right, a rectangle is a parallelogram with four right angles. I've also seen some people say four congruent angles. Well, if the angles are 360 and you divide that by 4, you get the 90-degree angles. All right, and then a square is a parallelogram with four congruent sides and four right angles. So these figures are all parallelograms. That means they have all the properties of a parallelogram plus other things. And the other things we start off with is that the definitions, which is four congruent sides, four right angles, and then the square is a mix of both of those. Okay, so our first property here, or our first theorem here, is that a parallelogram is a rhombus, then its diagonals are perpendicular. So make sure you put all of this information into your notes right here. Okay, so if you have a rhombus, the diagonals are perpendicular. That's the most forgotten property about that figure. The next one says that if your figure is a rhombus, then the diagonals bisect a pair of opposite angles. So your whole entire angles are congruent, opposite angles are congruent in parallelogram, but in a rhombus, each of these angles are bisected. So again, get this into your notes. All right, each one of these. So the whole angle BAD, so this whole angle right here, is bisected, so angle 1 and 2 are congruent. Same thing is true for ABC, which means 7 and 8 are also congruent. So the angles are bisected. All right, the next one, this is a rectangle. Okay, by the way, those were the only properties of a rhombus. Now, the rectangle has this one property, which is that the diagonals are congruent. That means the length of AC and BD are congruent. So the diagonals are congruent. Now let me remind you that the diagonals still bisect each other. So remember, get this into your notes. Okay. So here's something I want to show you that's kind of interesting about a rectangle. If I look at the rectangle, all right, and I put my diagonals in here, each diagonal is congruent and it's bisected, which means this piece and this piece are the same. This piece and this piece are the same. So what kind of triangles do we have in here? So what kind of triangle is that right there? You should know. And that is an isosceles triangle. And if that's an isosceles triangle, that means this angle and this angle are congruent. And so if we have a different isosceles, that means this angle and this angle are congruent, and this angle and this angle are congruent, and this one are congruent. And remember the opposite angles, so like this angle here and this angle here, they're still congruent because they're alternate interior angles. Watch out for this because this is a isosceles triangle and they have properties. Many people forget about that. The other thing I'll tell you to watch out for is there are some other things going on in here too. If I look at this little highlighted part, don't we have an exterior angle going on there in the inside of the triangle, rectangle? So remember those few things. Those isosceles triangles that are made because of the diagonals being congruent. That's the only other property we have of a rectangle beside its definition, which is four right angles. Now we got one more other thing going on in here. If I have a rectangle, what kind of triangle is that? Well, that's a right triangle because you have a right angle in the corner. So you can do Pythagorean theorem in a rectangle. So before I go on here, I'm just going to add one more page in. There are no properties besides the definition for a square. So that means a square, if I look at one, has all the sides congruent, which is like a rhombus. It has the right angles, like a rectangle. Okay. It is got congruent diagonals like a rectangle. So that means this is congruent to this, and this is congruent to this. And that means it also has all the bisected angles like a rhombus. And it has the perpendicular diagonals like a rhombus. And it has all the properties of a parallelogram. Opposite sides congruent, consecutive angles are supplementary, opposite, sides are congruent, opposite angles are congruent, diagonals bisect. It has everything. So it has all the properties. So make sure you know it. right, so here we have a little basic problem I want you to work out. It says here, the following figure is a rhombus. Find the measure of all the numbered angles. So we want the measure of angles 1, 2, 3, and 4. So pause the video, take a second to work through these problems. Okay, so let's look at the angle 1. If I'm going to find angle 1, remember that because this is a rhombus, the diagonals are perpendicular, which means angle 1 should be equal to 90 degrees. Angle 2, well, if this is a rhombus, remember that it's also a parallelogram, so alternate interior angles are congruent, which means angle 2 should be 58 degrees. Angle 3, well, remember that because this is a rhombus, the angles are bisected, which means this angle and this angle are the same. So that means that it's 58 also. Well, if I know angle 3 and I know angle 1, then I can use that to find angle 4 because that makes a triangle, which I get angle 4 is 32 degrees. So you need to be able to work through the angles of a rhombus. If I just give you one, you should be able to find every other angle that is in that figure. Okay? All right, our next problem says here, find the diagonal length. So it says this is a rectangle, okay? And if it's a rectangle, we know that the diagonals are congruent. And so we're going to use that to figure out which one of these is the right answer. So if you want to pause the video and work through this, that'd be great. If you don't know what to do, you can keep the video going and just see how it's done. All right, so the first thing we want to think about is that we know that the diagonals are rectangular congruent, and so their lengths are equal, which means that SF is equal to RB. Since we have equations for those, we're going to take those equations and make them equal to each other and find the value of x. So when I do that, I get 2x plus 15 equals 5x minus 12. 15 is equal to 3x minus 12, so we get x is equal to 9. Now I want to know the length of the diagonal. Now SF is one of the diagonals, and RB is one of the diagonals. They're both the same length, though. So we're going to take that value and plug it back in. And when we do this, we get the diagonal is 33, so the correct answer was D. Okay. Now, what about if I asked for, and I put a letter here like C and asked what was RC? You'd have to take the 33 and divide by 2, which way we get 16.5. So be able to do not only find the whole diagonal, but half the diagonal too, because we have to remember the diagonals are bisected. So I can do lots of different things with these numbers. I could only give you half the diagonal, and you got to double the diagonal in lots of different versions like that. That's what the homework gives you practice doing. All right, so just so you can see this is a Venn diagram of the world of parallelograms. So if we got all the parallelograms in the world, they're all inside this big box here, which is the world. And so inside parallelograms, there's a group called the rhombuses. Okay. And then there's a group called the rectangles. And when those two groups get together, when they have both the properties of a rhombus and the properties of a rectangle, they become a square. So know that some rhombuses are squares, some rectangles are squares. But all squares are rectangles and all squares are rhombuses also. And all three of these are all parallelograms. But not all parallelograms are rhombus, and not all parallelograms are squares, and not all parallelograms are rectangles. There are figures that are just parallelograms. So it's kind of good to see how things overlap here. Okay. All right, so I wanted to give you this one. Here's a chance for you to practice and find the measures of the angles. If you want to pause the video and find all the measures of the angles, and I guess I will just give you this little information here. This is a rhombus, and this is a square. And find all those angles. Okay, so if you're done now, you only got two angles over here. It's either 45 degrees or it's 90 degrees. So everything's 45 or 90. All right, over here at this one, remember that this was 53. These are right angles. So this is going to be 37, this is 37, this is 53, this is 53, this is 37, this is 37. I would suggest putting the properties of these figures on note cards so that you can review yourself over these properties. If you know the properties really well, then when it comes time to do the algebra, you'll know what to do. Okay? All right, so let's keep continuing on with our lesson. We want to be able to prove that a figure is a rhombus, rectangle, or a square. Okay? And so this can be done with using some of the properties that we know about diagonals. Okay? So in this theorem here, it says if a quadrilateral is a parallelogram with perpendicular diagonals, then that quadrilateral is a rhombus. And so remember to go ahead and get this into your notes. I didn't mean for that to be pink, but that's all right. Okay, so get that into your notes. So if you got a parallelogram, diagonal perpendicular, it has to be a rhombus. So even if I don't know the side lengths, I know it will be a rhombus. At the same time, if I know a diagonal bisects a pair of opposite angles, then I know that this is going to be a rhombus also. Even if I don't know anything about the lengths of the sides, if I know the angles are bisected, one pair, then I know it's going to be a rhombus. Okay. I also have to know that it was a parallelogram, though. All right, so the next one. I know if a quadrilateral is a parallelogram with congruent diagonals, then the quadrilateral must be. So I'm saying if I got a four-sided figure and I know the diagonals are congruent, it has to have four right angles and be a rectangle. All right, so again, get this one into your notes. All right, remember, we don't want to know the theorem numbers. We want to know what they say. All right, and so here's another one. If a quadrilateral is a parallelogram with perpendicular congruent diagonals, then the quadrilateral is a square. So if I have my diagonals are perpendicular and congruent, I know I'm going to have a square. So here's my last one. All right, and that's how you prove something's a square. Now remember, you can always use its definition. Definition says if it has four congruent sides and four right angles, it's going to be a square. So there's two ways to prove something's a square. There's more than one way to prove a rectangle. You can prove it by diagonals, or you can prove it by its definition. You can always use its definition as a reason to prove it is what it is. All right, so pause the video, work these 6 problems. If you have any issues with these problems, make sure you ask in class the next day, and we'll go over those. Okay. All right, so here's another page. We got a few more questions I want you to work on. So it says here, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? So if you want to pause the video and try what you think these 3 figures are, that'd be great. All right, so if we look at this one is a rhombus because the angles are bisected. And not only that, but also look, these sides are going to be parallel, these are going to be parallel. So it is a parallelogram, but it's because these angles are bisected, that's going to make it into a rhombus, because that's only happens in a rhombus. All right, this figure right here, this is going to be a rhombus also. Because remember that if it's quadrilateral with a perpendicular, actually, you know what? No, that's not a rhombus. Oh, they told me it was a parallelogram to start. So then, okay, it is a rhombus. We can let that be true. Got to read the question carefully all the time, guys. And then finally, this last one. This, we don't know. The diagonals are not, they're bisected. That's a parallelogram property. We don't know anything about the angles, so I would say it's just a parallelogram. We don't know if it's a rectangle, a rhombus, or a square. It only has the properties of a parallelogram. Remember that the diagonals are bisected, and that's a parallelogram property. It has nothing to do with the rhombus, the rectangle, or the square. All right. And that's it for our notes. And remember that on Monday, you'll be working on this stuff. Remember that the test is only 6-1, 6-2, and 6-3. So the rectangles, rhombus, and squares, not on test. Okay. Remember to do your review over the weekend too. It might help you to be prepared for the test on Tuesday. Thanks.